All right, let's talk about a little bit of formulas with rational expressions. These, we've seen some formulas previously. Formulas just meaning there's some application out there that has a relationship among different quantities. We've talked about the perimeter formulas and things like that. A few more here, and these formulas are going to have rational expressions in them. For example, here's a formula. 1 over f equals 1 over p plus 1 over q. Okay? Nice little formula. And describes the relationship between f, p, and q, some quantities that we have. All right, now, the first thing I would show you is this. Let's say we know two of the quantities. If f is, say, 6, and p, let's say it is 10, well, let's find the value of q. F is 6 and p is 10. Find the value of my q. All right, well, yeah, we're going to take and plug in some numbers here. In this case, I've got f is 6 and p is 10. Q is my unknown. All right, and yeah, so how am I going to find the value of q? Well, just to give you a heads up here, q is not negative 4. Yeah, these are fractions, and so fractions work a little bit differently here. No, we bring up this particular problem now because this is just a fractional equation. Rational expressions here. This is what we've been talking about a little bit. We're going to have to solve this rational equation with rational expressions in it. How do we do that? Well, a couple of techniques. There's cross multiplying, but you can't do that here because you've got more than one fraction on the right. Cross multiply, you need one fraction just on each side. Now this one here, what I'm going to do is use the LCD technique, come up with the LCD of all my denominators, the least common denominator of the denominators, which in this case, well, I need a factor of q. That's in there, so I need it. Then I've got the just the numbers, 6 and 10. What multiple do those have common? How about 30? 30 is a multiple of 6. 30 is a multiple of 10. Yeah, just think of the multiples of 10. See which ones match up with the multiples of 6. 30 is a multiple of both. Okay? Now remember what I do with that is I take that and multiply it by all the parts. 30q times 1 over 6 equals 30q times 1 over 10, and then 30q times 1 over q. All right? So what I do is I do some canceling here. Cancel the 6 into the 30. It gives me 5q. The 10 cancels and leaves me 3q. And then the q's cancel. That leaves me 30. Okay? All right. Solve for q here. So we got minus 3q. 2q equals 30. That's what we have then left. Divide by 2. Q would be 15. All right? Okay. All right. Let's try another one of those. E over little e equals big R plus little r over little r. All right. What I want to do here is let's find the value of little e if Big E is 800. Big R is 55. And little r is 15. Okay, so what do we do with that? Well, again, we've got numbers, so we can plug in some numbers here. Big E is 800. Little e, I don't know yet. Big R, well, that's 55. Little r is 15. And little r is 15. Okay. Well, we can, of course, add. Go ahead and add the 55 and 15, so that's 70. So 70 over 15 is the right side. Okay, now what do we do? Well, this is one where, we've got one fraction on each side. So anytime you have one fraction on each side, we can do what we call cross multiply, which means it takes the top on the left times the bottom on the right, 800 over 15, and then the same thing, top on the right times bottom on the left, it'll be 70 times E, and those two things must equal. Gives us a nice little equation to solve. Let's see, 15 times 800, let's see, that's going to be, I believe, 12,000, sorry. 12,000 equals 70E. All I have to do then is divide the 70. Those reduced by 10, so that's going to give me 1,200 divided by 7. That's E. Okay? All right. Now, let me take that very same formula and do something a little different with it. Big E over little e equals big R, little r over r. Same formula. However, in this case, I'm not going to give you any numbers to plug in. We're just going to solve for a variable here. We're going to solve for big R. Did a little bit of this previously, but do a little bit more here. Just solve for big R. Don't have any numbers to plug in. Just going to have to get big R. Well, what do I do? Well, very same thing. I just don't have numbers to plug in. Can cross multiply still, so I'm going to multiply the top times the bottom, so we get E little r. And then the top here times the bottom over here, so that's going to be E times big R plus little r. Well, of course, the goal is to get big R by itself. A number of ways we can do that. If we go ahead and distribute the little e there, we have big E R equals E big R plus E little r. Need the r term, get it by itself, so I need to move this little ER term over, so I subtract it. So I have big ER minus little ER equals E big R. Divide off the E then. There you go, because the E's cancel out, so we just have R. Big ER minus ER over E little e. That's my R. Okay? All right. Let me do another one of those. I equals N E over R plus N little r. Got some same variables there. A few different ones though. Let's solve that one for big R then. Okay, well, this one again we can think, we want to make it a fraction, I over 1. Let's redo it here, or write it there, whichever one. And we can do the cross multiply again. Top here times the bottom over there. So that'll be I times r plus n little r. And then ne times 1 is just ne. This is the equation we get. Again, distribute the I here. IR would equal, or plus I in little r equals NE. Trying to solve for the R, so move the I in R term, subtract it. And so IR equals NE minus I in R. All I have to do then is divide off the I. All right, NE minus I in R divided by I. That's what I'm looking for there. Okay? All right. Yeah, let me show you one more. This one actually, we have to supply our own little formula, but that's what I want to talk about. All right, let's say we've got Bob, and Bob can clean his house in 10 hours. So his wife can clean it in 4 hours. Question then is, how long does it take them working together? How long together? Okay? All right. So theoretically, anyway, if Sue can do it in 4 hours, it should take less time, right? If she gets a little help from Bob, Bob takes his time a little bit, but if he gives a little help, it should take him, less time than 4 hours. Well, you might be thinking, well, let's just average the two, but the average of the two, 10 plus 4 is 14, divide that by 2, you get 7. That gives us a number between them, so that's not what we'd want to go here with. Yeah, like I said, there's a formula that's involved, and here's the way it goes. I call it the work formula. The other problems won't necessarily be cleaning a house problem. It might be some other form of work, but here it is, work formula. One way you can do this. All right, it works this way. If you take 1 over one of the times alone, add to that 1 over the other time working alone, that's going to equal 1 over time together. It's kind of a rate comparison. Rate plus rate equals rate together. It's kind of the idea. Okay, so yeah, let's see what this gives us in this particular case. All right, so what have I got? 1 over one time alone. So let's do Bob's time. So that'd be 1 over 10 plus 1 over the other time alone. That'd be Sue's time. So that'd be 1 over 4. And that equals 1 over the time together. We don't know what the time together is, so that's our x. So this is going to be 1 over x here. Okay? All right. So this is our little equation we go about solving. And in this case, if we just leave it as is, yeah, we can do this one using the LCD technique. Just come up with the LCD of all three denominators there. You've got x, so you're going to need a factor of it. 10 and 4, what multiple do both of those have? Well, 20 is a multiple of 10, 20 is a multiple of 4. So I can use 20 for those two. So 20x will be the least common denominator. Then with that, then I take it and multiply it by all the parts there. So it's 20x times 1 over 10, 20x times 1 over 4, and then 20x times 1 over x. And then nice things happen canceling wise. Yeah, that being 20 over 1, and cancel the 10 factors there, common factor of 10. Leaves me a 2 for the 20. So I have 2x times 1. That's 2x. Here, again, 20 over 1, so I've got a 4. I can cancel a factor, right? So 5. So what would be left? So 5x times 1, that would be 5x. And then on the right, the x's cancel, so that's just going to be 20. 20 times 1 gives you 20. There we go. Much nicer equation now. 2x plus 5x, well, that's 7x equals 20. And then we divide off by 7. We've got x is 20 over 7. So the time together, 20 over 7, which is, you change that to a mixed number, it'd be 2 and 6/7 hours. Which makes sense. It's a little less time than Sue's time, so there you go. That's how you solve our little work problem.